Hello everyone and welcome back to our second video for Unit 1. Today we're talking about segments and angles. So let's go ahead and dive right in. Alright, segments. Segments that have the same length are called congruent. So essentially congruent means kind of like equal, but it really means same shape, same size. So when we identify congruent segments, we're looking for two segments that are the same shape and same size, but we can't just assume that they're congruent. There has to be something that is identifying them to be congruent. In the case of segments, we have something called tick marks, and those are what tell us that the segments are congruent. So we identify congruent segments by using tick marks, and they are on the image to the right. I'm going to go ahead and darken the tick mark so you can see it a little bit better there. There's one, there's the other. So our tick marks right on the line. The symbol we use to say two segments are congruent is, let's zoom in here a second so you get a good look at it. It's an equal sign with what we call a tilde, or some people just say a squiggle. But it's officially called a tilde. This is the congruent symbol. Equal sign, tilde, means congruent. So if we were to look at the drawing to the right and draw an example, if I were to say that segment PQ is congruent to segment RS, I would write it out as PQ, with a bar above it, is congruent to RS. So this is what that would look like. Segment PQ is congruent to segment RS. Alright, let's go ahead and look at this postulate here. The segment addition postulate says if B is between A and C, then AB plus BC is equal to AC. Alright, so let's go ahead and draw an image to the side over here. We're going to draw out what that might look like. So I have this line here, and on one end I have point C, and on the other end I have point A, and it says that B is somewhere between A and C, and it doesn't say where, so I'm just going to stick a point on there and call that point B. So now I have B is between A and C, then AB plus BC is equal to AC. So this small section added with this longer section from B to C should add up to the segment AC, which, if you think about it, makes sense. If you're taking two segments and putting them together, then the whole segment will be equal to those two pieces. Alright, so let's go ahead and look at some examples with this. We have letter A here, and we're trying to find the length of JL in each problem. So I have JKL, so if I'm trying to find the length of segment JL, I need to take my two smaller chunks and add them together. So the reasoning behind this from our postulate says that segment JK plus segment KL is equal to segment JL. So because of this thought process, I'm going to go ahead and say that 19 plus 48 is equal to segment JL. 19 plus 48, 9 plus 8 is 17, carry the 1, 4 plus 2 is 6, so we are looking at 67. JL is equal to 67, and that would be units, as this is not labeled to be inches, miles, or anything, so we just say units. Alright, letter B looks a little more complex. We have JLM, and we know the length of the whole segment, but we only have equations for the two smaller pieces. So if you're given a formula for something like that, you're going to go ahead and you're going to notice that, okay, 143 is equal to 7y plus 9 plus 3y plus 4. So we're going to go ahead and write that out. 143 is equal to 7y plus 9 plus 3y plus 4. Alright, I'm going to go ahead and combine my like terms. 7 plus 3 is 10, so I have 10y. 9 plus 4 is 13, so I have 13. And that is equal to 143 still. I want to get my y by itself. The first thing I'm going to do is get rid of this number that doesn't have a variable with it, because those are easiest to move. So I'm going to subtract 13 from both sides. That leaves me with 130 is equal to 10y. I'm going to divide the 10 out to get y by itself, and I divide that on both sides. So that leaves me with y is equal to 13, because our zeros just cancel out there. So now that I know what y is, I can go ahead and I can plug this into my equation for segment JL. So I have JL is equal to 7 times y, which is now 13, plus 9. 7 times 13 is equal to 91. 91 plus 9 is equal to 100. So I can say that segment JL is equal to 100 units. Alright. Next we have something called a midpoint. A midpoint is the point that divides a segment into two congruent segments. So if we were to go back up to these pictures, it would only be a midpoint if each side was congruent. Along with a midpoint, we have this little thought bubble here. What does the prefix bi mean in the words binoculars, biweekly, and bisect? Typically you would say 2 when you're thinking bi. If you're saying bisect, you're really saying you're cutting it into 2, or in other words, you're cutting it in half. So the midpoint of a segment is what we call the bisector of a segment, or the segment bisector. And so the midpoint of a segment is what we call the segment bisector. So let's write that out here a second. Segment bisector, or bisector of a segment. In other words, the midpoint cuts the line into two congruent halves, two equal sides. Alright, let's go ahead and look at some examples on the next page here. Alright, apply what you know. B is the midpoint of segment AC. If segment AB is equal to 4x minus 7 and segment BC is equal to 5x minus 15, find the lengths of AB, BC, and AC. Alright, whenever I get to a problem like this, the first thing I like to do is draw a picture. It just makes things easier to understand what's being said in the words. So let's go ahead and draw segment AC from A to C. And it says that B is the midpoint, so B is exactly halfway between A and C, which means that AB is congruent to BC. Then it says that AB is equal to 4x minus 7 and BC is equal to 5x minus 15. Well, because AB and BC are congruent, then 4x minus 7 must equal 5x minus 15. So let's go ahead and write that out. 4x minus 7 is equal to 5x minus 15. We're going to go ahead and solve for x, and then we can use x to solve for our missing side lengths. So I'm going to go ahead and start by moving my negative 15 over to the other side by adding 15 to both sides. That leaves me with 4x plus, because our positive 15 is outweighing our negative 7. So in other words, you could think of this as 15 minus 7, and that leaves us with 8. And that is equal to 5x. Now I want to get this 4x with all the other x's, so I'm going to subtract 4x from both sides, which means that x is equal to 8, because 5 minus 4 is 1, We just write just x. All right, now I'm going to take this x value and I'm going to pick one of these equations to plug it into. It doesn't matter which one. Because A, B, and B, C are congruent, it's going to be the same answer regardless of which one you pick. So I'm going to go ahead and pick AB. So I have AB is equal to BC, which is equal to 4x minus 7. And I'm going to go ahead and plug my x in. So I have 4 times 8 minus 7. 4 times 8 is 32. 32 minus 7 leaves me with 25. So this is equal to 25. AB, segment AB is equal to segment BC, which is equal to 25. Because both segments are equal to 25, if I draw on my picture over here, from A to B is 25, from B to C is 25. If I want the whole piece, I then need to add my two section lengths together. So I have AC is equal to 25 plus 25, which is equal to 50. And this is my answer right there. I have all three pieces. Segment AB is congruent to segment BC, which both equal 25, and segment AC is equal to 50. All right, so now that we've done a little bit of work with segments, we're going to take a look at some angles. First off, an angle is a figure formed by two rays with a common endpoint. So if we're thinking in our definition what these specific words mean, when it says that it's formed by two rays, those rays are what we call the sides of our angle, and the common endpoint is what we call the vertex. Now that we've talked about what is an angle and the parts that make up an angle, we want to talk about how do we name an angle. Every angle has 3 different ways for how you can name it, which result in 4 different names for the angle in this situation. The first way to name an angle is with the endpoint. So I would just take that endpoint, and in number 1, I'm going to draw an angle marking, and I have angle R. So this angle is angle R. The second way is using the number that is inside of the angle. So this number 1 tells me that I have, for option number 2, angle 1. For option number 3, you take the end point and any other point from each ray and you put them together with the common end point in the middle. So I can say that for option number 3, I have angle SRT. Again, make sure that R is in the middle, and this angle measuring is what tells us that we're working with an angle. That differentiates this from a plane, which has no markings at all. Our fourth option is actually the same as number 3, but it's in reverse. So we're going to start on the other ray with T, go to R, and come to S. So my fourth option is angle TRS. All right, so now that we've named our angle, let's go ahead and do an example. So we want to name all 3 angles in this diagram shown right here. I have the large exterior angle here. I have the little angle on the inside from B to A to C, and I have this other angle here. I'm going to go ahead and start with the largest angle that encompasses the other 2. So I'm going to start with B, go to A, and go to D. So I have angle BAD. Alright, now I'm going to do this interior angle here, and I go from B to A to C, so I can say that I have angle BAC, And that leaves angle CAD as our third angle. In this image, you might notice that we have more than one angle with that shared endpoint. That's why using the 3 points as an angle name is almost always the best option, because if we had just this A and we didn't have names for the other endpoints and I said angle A, you wouldn't know which of the 3 angles I was talking about. Alright, so now what if we have 2 angles that are exactly the same? What do we call them then? Well, we call them congruent as well, because, reminder, congruent means same shape and same size. So we would have the same shape, same size. Now, these aren't necessarily congruent because they aren't marked that way. If they were congruent, you would have a arc that is the same in both. If one of these had 2 arcs, so let's say angle CAD had 2 arcs, this tells me that this angle is not the same size as this angle, because this one has 1 arc and this one has 2. Alright, let's go ahead and switch to the next page where we'll get a little more information about how we measure angles and how we can prove that they are congruent. So when we measure angles using a protractor, which is pictured here. And that is a protractor. Checking spelling there, and that's correct. Alright, the units for angles is degrees. And there are 360 degrees in a circle, and a protractor is half of a circle. So this has half the amount of degrees, so there are 180 degrees from one side to the other. Alright, before we find the angle measures that we're being asked to find, I'm just going to do a quick refresher on how to use a protractor. If your angle starts to the left of the vertex, that common endpoint, then you use the outside angle measurements. If your angle opens with your bottom side to the right of the vertex, then you use the inside measurements. Alright, so first it says to find the measure of angle EOD. EOD. Since E to O goes left from O, we're going to use the outside measurements here. So I'm at 5, 10, 15. Okay, so because D is at 15, that tells me that this angle opens up 15 degrees. So in this case, all I have to do is write right next to EOD that this is equal to 15 degrees. Next, it asks for angle DOC. Okay, well, I found that D was at 15, and that's our starting line for our angle. Because this isn't on 0, I can't just find the number that this is sticking out at. I have to do some subtraction. So I'm going to go ahead and figure out where C is at, and then we're going to do C minus D. So I'm on the outside measurements, because I started on the outside over here. 95, 100, 105 is what that looks like to me. So if C is at 105, I need to do 105 minus 15. 5 minus 5 is 0, and 10 minus 1 is 9. So that leaves me with angle DOC is a right angle, so this is equal to 90 degrees. Alright, last but not least, we have angle AOB. So I start from A, go to O, go to B. This time, my angle is lined up to the right, so I'm going to go ahead and I'm going to use those interior measurements. I am lucky that this is right on that tick mark, so I can tell that this is at 40 degrees on the inside there. So because we open up 40 degrees angle AOB is equal to 40 degrees as well. All right. Now we have a few more types of angles here, and we'll go ahead and draw some pictures to the right of what these look like. So we have 4 types of angles here. The first one is acute. An acute angle measures greater than 0 degrees but less than 90 degrees. So it's greater than a ray but smaller than a right angle. So it looks something like this. I often hear people say to remember what acute means, that it's a cute little angle. All right, a right angle measures 90 degrees. So that is our L-shaped angle. When you are drawing an example of a right angle, you need to make sure that you get that square in the corner of the L. That square is what tells us that that is a 90-degree angle and that it is a right angle. Our third type of angle is an obtuse angle. It measures greater than 90 degrees but less than 180 degrees. So we're going to have a larger opening than what we saw in our right angle, but it can't be a straight line. So I have something that looks like this. That is an obtuse angle. Greater than 90, less than 180. Our fourth type of angle is a straight angle, and that measures 180 degrees. Another way you might think of a straight angle is a straight line. Goes from, or 2 opposite rays, they go in opposite directions. So this is a straight angle, it measures 180 degrees. All right, this is where we're going to go ahead and stop for today's lesson. We'll pick back up in our next video with more about angles and pairs of angles.